We're looking at some Rust code today. We're looking at Kanidm or Kanidm. They tell you how to pronounce it. I probably should have looked at that before I went live. But it's an identity management system, or IDM, hence the IDM at the end, written in Rust. That's kind of a detail, except that I'm going to have to read Rust code today, and I don't know Rust. I've looked at a little bit of Rust code before, but if you are a Rust station or Rust station adjacent, you will notice that I just don't know what I'm doing. So we'll try to make the best of it. And if you have tips and tricks for understanding Rust code, or if I come across some sort of construction that I don't know, that you know, and is obvious and you're shouting at the screen, feel free to shout into the comment boxes, although please don't shout. But any tips, tricks, useful feedback, sports betting tips, great horses to bet on, favorite songs, those all go in the comment box. Okay. So I didn't know about this project, which I will look up the pronunciation before I say it too many times. I swear they tell you how to pronounce it. Is it in the README? Pronounce like Carnidm, maybe all with the same stress. Carnidm, I don't know where the R comes from. Carnidm, I guess, is so I came across it because I needed an IDM system. I wanted to add users and groups and stuff to my home lab, my homey labby. And I was originally trying to make free IPA work, and I was playing around with free IPA, trying to make that into a containerized version. And I had some success, but it didn't really want to be run on Kubernetes, which is where I'm running my other stuff. They had a config that made it work. So if you're saying that you run free IPA on Kubernetes, I'm aware that it can work. But the restrictions on getting the domains and the DNS routing and the systemd stuff all working were rather constraining. And so I found Kanidm as an alternative that was maybe more modern, less like the Active Directory days where everyone's on the same intranet, on a trusted intranet. And maybe, I think Kanidm is perhaps a little bit more consistent with a, maybe not zero trust, but maybe less trust environment. Is that right? Let's check the sanity. Let's sanity check this. How consistent is this thing with a zero trust approach to networking? I just don't want to make any claims that they don't want associated with their product. That's the reason I'm being a little bit cautious. Well, the AI search mode of Google says it's highly consistent. What are good Beyond Corp style, zero trust, open source projects? So we'll ask it that, and then we'll go back to the code. Their documentation so far I found to be really good. There are some things that seems like they haven't quite gotten to, and that's fine. And but otherwise it's good. They don't seem to do federation well. Or rather, it doesn't seem to be a priority, which is okay. They do like synchronization. So I don't think we're going to look too much at that. I think I want to look at the kind of core code, maybe the hot path, if you will, the sort of hot path in the sense of like security. What's the most security sensitive code? Because I think that will tell us a lot about what the primitives are, how they're thinking about modeling security, and so on. All right, so onto the code. They really want me to call it Kanidm. I don't know if I have it in me to put that R in there. This is listing a bunch of zero trusty stuff. Teleport, Cerbos, OpenZD. Thought it was OpenZit for a second, which is a separate thing. Okay. Let's plow along. They have a code of conduct too. And they have like a comparison with things like free IPA and what is it? LDAP2, that sort of stuff. All right. Kanidm. Okay, I'll try it. I've gotten GNU and GNOME down, although I don't love it. So they have examples. I don't know if examples is good. Book, I think, is really their website. Or maybe they are publishing a book. I don't know. Book.toml. And it's in maybe LaTeX accounts. No, it's in Markdown. Okay. Okay. So we're going to ignore those. Libs, we'll look at platform. Proto, I assume is maybe protocol. Kanidm is going to be like Python bindings. I don't know if the client is in Python. I don't really know anything. But I want to like go for the jugular here. So I'm guessing that's probably libs. Crypto, client, file permissions, profiles, SCIM proto. SCIM. I know I've heard that acronym. How information is exchanged between one entity and another. Cross-domain identity management. So this is for what? Synchronizing users of your user identity information between identity domains or IT systems. Okay, so that is not, I think, what we need to look at. And then in platform, these are the different, like, maybe builds they have, like Debian, Fedora. I don't know what auth select is. Let's find auth select. Looks to be some utility that lets you select authorization stuff or authentication. And then proto. We have source and stuff. So CLI presumably is the command line API thing. And then these are maybe just the protocols for authentication or authorization, whatever mod is in Unix. I think maybe Unix is, they have, they should support things like logging in, if you have your corp users in a Kanidm instance, they should support things like logging in as a LDAP kind of database, as well as things like SSH. So that might be what Unix is about. We'll skim these quickly. Authentication in Kanidm is a stepped process. The session is first initialized with the requested username. In response, the list of supported authentication mechanisms is provided. Okay. I guess this makes sense. I don't know how else it would work, but so you can if you go to a website like Gmail, let's say, if you know what the authentication method is, it's the password, and then there's some stuff behind the scenes. But I think that this is okay. My first reaction is you don't want to give away information like how long the password is or whether the user exists on the system. I don't know if this violates that, because if you request a username, you'll get back authentication mechanisms, I think, if it exists. But I'm not sure if that matters. And then auth step is initialize a new authentication session. We're going to call init. I don't know Rust. The syntax, I assume, means init takes a string, namely the name. What kind of string? What format? I don't know. Like UTF-8, ASCII. I'm not sure what string is in Rust. And then init2 is maybe the second phase of the init. It's going to take a string, initialize a new authentication session with extra flags. Okay. This is maybe like an interface, and these are maybe two optional methods or something, like one that takes a string, one that takes an auth issue session. And then if true, privileged means you can have read-write access to what? I don't know, some of the Kanidm files. And request the named authentication mechanism. So I guess this is not like a chain of commands. I'm assuming pub enum, they use maybe enums as interfaces. In Rust are enums used like interfaces. What do you think of using enums as interfaces between blah, 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 structs? The basic rules use enums for closed sets and traits for open sets. Okay. So I'll take that as a yes, that this is essentially an interface. And then we have begin and cred. Begin takes an auth mech. Draw an auth mech. Mech in the sense of robot, auth in the sense of authorization. I didn't need to ask that to pro, but I did by accident. Make the mech super mech. Okay. This was telling us about other projects, right? Is that what this was about? Netbird. I don't know any of these things. I don't know if I can read this later. Can I read this later? A specific Google search? That's better. Make it more... Make it look more like it's authenticating and authorizing users at a boring office. Okay. Then we have auth state. And you select how you want to proceed. You can choose some auth mech. You can continue to auth. So I guess that's maybe like a stateful thing, like as it mentions challenges, like maybe a challenge response thing. Or maybe you need both like a password and a second factor. Maybe that's what continue is about. And then you say denied or success. The really simple API for the auth step for these protos. And I'm thinking that this, I don't know what the convention is, but I believe that these enums are for like the API. My sense is these are for the API rather than like necessarily being the same as the underlying business logic under the hood. And then here's a credential challenge. A credential challenge. So we have an auth credential, which is an enum that is anonymous or password or top T, time-based one-time password, which is the Google Authenticator thing. A security key, which is some public key credential that is boxed. I don't know if this is like boxed typing in Java and other languages. And then we have a backup code, which I think is like the Google Authenticator backup code thing. And then we have a passkey, which is different from a security key, but is also a public key credential. And should this be discoverable? I don't know. Okay, so that's what this stuff is about. So far, so good. Seems pretty simple, straightforward. Here's mod.rs. Items defined in this module will remain stable or change in ways that are forward compatible. So there's some forward compatibility promise. And we have what? Account type, UAT purpose status. Maybe mod is a convention that you like import mod as opposed to other stuff. This is maybe an entry point. I don't know what UAT is, user auth token. So the user auth token has a status. And the status includes the account and session IDs, the status state, when it was issued at, which is an offset date time. Do you want the date time to be offset or absolute for security? I don't know. And then you have a purpose status. Okay. And then Unix stuff has a key type schema with a name, a short name, is cert, is SK. I don't know what SK is. Signing key? I don't know. The kind and whatever plain static string is. Plain text? No, that can't be it. And then a Unix group token, a token representing the details of a Unix group. So this is for the, I think like LDAP style functionality. We've got a string, an SPN, a UUID, and a GID number. I don't know what SPN is, something number maybe. And then a Unix user token is probably similar to group token, but for users. We've got, and so they've got display names. Let's see if SQN is Unix thing. Sequence number? Successive approximations. Oh, sorry, SPN. Did I look for SQN? That is my problem. Service principal name. Each server instance must register a unique service principal name to identify itself, and the client must specify the same SPN when it connects to blah, 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 blah. Registering the service principal name. Creating an SPN from a Linux build server. Service principal name. Let's see if it has a Wikipedia page. Oh, it's maybe part of Koorosh, the three-headed dog. It's been a long time since I've seen the Koorosh logo. Not bad. It looks like it's kind of like a washed out photo. When was this logo made? Is this logo from 1989? I don't know. What can we find out about it? It's from MIT. Do we have copyright info? Logo used by the developers, blah, 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 blah. For the Koorosh protocol. Image is less than 300 by 300. Okay. I don't know when the image is from. All right, this is a authentication mech. Not bad. Shouldn't it be at some sort of boundary so it can decide who gets in? An authentication mech is essentially a robot bouncer. But what I wanted to do is we're here in was that it? Was it auth.rs? I wanted to ask Yemeni about the auth step. Where is it? I'll just grab this. So Kanidm says this about their auth flow. Does this leak the existence of a user and their auth methods if an attacker tries to guess usernames? If so, is that how much does that matter? Hey now. That looks a little bit better, although everyone's already inside the office. Let's ask ChatGPT. Oh, I meant to ask the same question. Does this leak the existence, let's say presence, of a user on the system, as well as their authentication methods, and if so, how much does that matter? Okay, yes, it leaks the user, it leaks the authentication methods. How much does it matter? Low risk for internal systems. Enumeration may be tolerable if a system is behind SSO, VPN, or otherwise not internet facing. Username enumeration and method disclosure are usually considered sensitive information leaks. Attackers can build a list of valid accounts, prioritize attacking weaker methods, tailor phishing, and social engineering. Best practice, opaque responses. Respond with the generic invalid credentials until some authentication method succeeds. Okay, so does Kanidm discuss this in their docs or elsewhere? It does not have an explicit discussion about username enumeration mitigation. It documents the flow, etc. Okay. So yeah, so how would you harden this? Seems like I don't know if there's a configuration knob, but it seems like you could just, everyone is expected to at least know a password. And then once they're passworded in, they can get back like a request for a second factor or whatever. I think that's how other things work. Okay, so that's what's in source v1 for the protos. And what else is in libs? We have client, crypto. Crypto might be cool. I'm optimistic that they know what they are doing with crypto. And that in that sense, the crypto is just, what's the word I'm looking for? Competently or correctly using crypto libraries that they did not write. We could just verify this. We have mtls, lib, cryptmd5.rs, serialized in x509 certs. There's using some x509 cert library. That looks good. mtls is the lowercase m is mutual TLS. I think there might be an uppercase M, but mainly what I want to know is, okay, so they're using some SSL, OpenSSL library. Is there an MTLS? Maybe there's not. I thought there was something that was really close to MTLS that people got confused frequently, but whatever it is, it may be something I'm misremembering. Okay, so the libs library doesn't look so, I don't know, maybe users? I don't know what sketching is. Or profiles, or file permissions, I think is probably not so huge. Server is reasonably big. Profiles. We have source. lib.rs, so small. CPU opt level. I think this is maybe about profiling in the sense of performance and not about like user profiles. Although users, I think is in the sense of users. We have Unix and lib. Get current UID, get current GUID. All right, it's not much here. What about lib? Not much here. Okay. And then sketching. We have lib, Mac. Oh, macros. I thought they said Mac OS with a something in between. So these are macros for, I guess, just for the developers. Like this looks like maybe debug tracing. Makes sense to do that in a macro, I suppose. And then profiles is the thing we looked at before, right? Although, like, what do these things actually do? This is some implementation. It's going to take a function. I mean, it is a function. Whoa. It's formatting some string for CPU opt level, blah, blah, blah. We're going to write some data. Apply profile. Transform any requested paths for our server. We do this by reading our profile that we've been provided. So we've got some build profile and we're going to maybe wrap functions or something. And then in server, we have core, daemon, lib macros, lib, and test kit. And I'm guessing this might be where a lot of the stuff is, although we haven't seen I don't think we've seen yet like the group hierarchy stuff. So we are missing something large. We're definitely missing the Unix integration. This must be the things that actually, when you call get GID or get UID, these are the things that must do the work. NSS is that for a log again? That's name service switch. Is a feature found in the standard C library of Unix-like systems. This is for declaring where you get things like usernames from like password or Etsy group, etc., or DNS. And so this is, and then PAM is the like pluggable authentication in Unix. PAM core. So this is implementing some PAM thing. Okay, so there's some PAM server, PAM client. Great. That is all sensible. So let's find out where groups are. group, class group. Maybe in Pi Kanidm. You asked me about. Oh no, did you? Hey, hang on. Did you? Was it a request? If so, I'm glad I'm finally getting to it, but I apologize for it taking me so long. I do have like a million requests. Let me pull up the request sheet in the other window. I don't have it in my list of requests, but I'm sure it's somewhere on Discord. Huh. I don't. Well, wherever it was on Discord, I don't see it. Oh, huh. Well, I'm learning more about it now. That's for sure. Yeah, sure. Oh, it was a DM. Okay, that's why I'm not seeing it. Yeah, you did. Yeah, okay, so I'm finding this. You were asking about the... I hope it's okay to share this. I'll keep everything else off screen. You're asking about contributing. That's cool. I think I basically said I have no idea here what this is. Yeah. Well, now I do. That's cool. Did you ever find out what to contribute to for Google Summer of Code? Let's see if we find. So let's see, we have groups in Pi Kanidm, and we have in the client, libs client, libs source, server, libs source IDM. That's where we want to be. How did we miss lib server? Yeah, this server core. Lib source. Okay, so it's like the server lib, I suppose, is the idea, as opposed to the root level lib. Okay, so this is where we want to be. We have IDM, constants, credentials. I don't know what a constant is, but we can probably ignore it. REPL is presumably like a shell, a REPL loop. Oh, cool. I like Podman a lot. How's that going? Are you having fun? We have migration data plugins, server, some value set, and then entry. Entry might be like a log entry. Event might be like an event that's emitted. We have lib. That's just a whole thing. Schema might be important. Status. I don't know. Value might be important. And then in IDM, I think this is where I want to start for just in general. Delayed. I don't know what delayed means. Something about being delayed. Cred update session, auth session, an audit. This is presumably like maybe audit compliance. Account policy, application, app links, group, identity verification, LDAP, mod, I'm going to guess is like kind of a module entry point, reauth, SCIM I will ignore, servers and service account I will look at. Oh, that's cool. Is Podman in Rust? Or does Podman use Rust? I don't know what NetAvark is. Rust netlink. Container network stack. Cool. All right. So back to Kanidm. In delayed, we have what? So we have some new for delayed action, like a password upgrade, other kinds of password upgrades, incrementing web authentication counter, removing a backup code. I don't know what makes these delayed actions, maybe like asynchronous. And then some debugging information. Password upgrade is some struct, which has a target UUID in the existing password, which is just some string. And then we have a type for a struct for authentication, an auth session record. I don't know what makes it delayed. There doesn't seem to be any delayed specific code in here. Here's an implementation of something, of the format debug. Okay, that don't matter. All right, but somehow those are delayed. Got it. Podman is written in Go and Network. Very cool. So you're writing Rust, right? If I understand correctly. And do you also write Go? Out of curiosity. Okay, here's auth session. It contains the logic to conduct an authentication of an account. Yeah. So this is authentication as opposed to authorization. That's cool. I'm going to practice using these emotes because I don't use this, and I don't really. Last time I tried to use it, I found it very confusing. How do I give you a thumbs up? Yeah, but I think I have to like actually send it, right? This is the search window. Where's the chat? I see. I had to select which version of thumbs up I wanted. That is cool. All right, now I have successfully used chat. Hash brown. Hash brown must be just a fun library name. It's implementing some hash set. Okay, so this seems like it's going to be long. I don't know if we get a line number. But we have some constants like bad password message, incorrect password, incorrect TOTP, etc., etc. I don't know if these are internationalized somewhere. Auth intent, which includes a initial auth, whether it's privileged. I don't know. Privileged as a bool. We don't have a lot of information about how much privilege it has, but I guess privilege has a specific meaning. And there's also a re-authentication for like if you need to re-enter your password or whatever to do something extra sensitive. A cred verify state, init success or fail. Cred state is success, continue, denied. We have a cred backup code with password, cred verify state, etc. We have a cred handler, the current active handler for this authentication session. This is determined from what credentials are possible from the account. Okay, so it could be anonymous, password, etc. Backup code. What is CMFA? Credentials something. At any rate, they have CMFAs and cred IDs. And then this is the cred handler in Noom. What do we have down here? An implementation of cred handler. Given a credential and some external configuration, generate the credential handler that will be used for this session. It's a self-contained unit that defines what is possible to use during this authentication session to prevent inconsistency. Okay, so let's see how it does. We've got build from set passkey, build from single passkey, build from set attested passkey, build from single attested passkey, build from password TOTP. Let's look at build from password TOTP. So you give it a credential, like I assume like a reference to a credential, and it's going to return an option of self, I guess being the auth session. So it's maybe going to return an auth session, maybe some sort of error, some sort of indication that authorization failed, or rather authentication, I think we're doing. So we're going to switch on the credential type, And if it's a password MFA, like a multi-factor authentication with a password, I assume, we're going to give it the password and the maybe TOTP. And if the TOTP is empty, we'll return none. Otherwise, we're going to look at cred TOTP. We're going to try to create like a credential struct by cloning the password, setting the state to init, like the cred verify state is being like initialized. We're going to clone. We're iterating over something, so I guess maybe TOTP has like some collection in it, and then maybe just the digits. I don't know. And then the MFA state is also being set to initial init, and then we're going to return some cred handler of password TOTP of CMFA, which is this thing, the thing I got from cred TOTP, and then cred ID is the UUID that's in the cred that was passed in. Otherwise, we return none. Okay, so this tells us a little bit about what CMFA is, and we can search for it, and it just really appears here. Credit multi-factor authentication, maybe credential multi-factor authentication. I'm going to guess. Okay, so that's the build method. So what it's returning ultimately is a credential thing that's initialized and says that it's in the init state. And so that must be handled ultimately somewhere else, I guess. Here's something to do a password upgrade. If the password requires upgrade, we're going to do some asynchronous transmission, sending the delayed action. Maybe delayed action just means we send it through this async mechanism of password upgrade. Validate anonymous. Validate that the client wants to authenticate as the anonymous user. And there's really nothing to do. We just say it's success. Or there might be a security error. So what throws the security error? Oh, if it says, I guess if you say that you want to authenticate as anonymous, but you don't give it the anonymous credential, you can't be anonymous, I guess. And then here's validate password. Validate a single password credential of the account. So you give it an auth credential, cred. You give it a UUID, the password, which I think would have been in the auth credential. Although maybe the type information isn't enough to like say that this necessarily contains a password because auth credential is pretty general. Although first thing we're doing is we're matching. So we're matching on password, and the password contains the clear text in the memory. And we're going to call password verify, taking the clear text, calling as string on it, and trying to unwrap. I don't know what unwrap is doing, but I guess if unwrap fails, we'll return false. And if the password bad list contains the password, like maybe if password is password 123, then we'll say that the password is found on the bad list. Or I assume this is for password. I don't know what this is for, but this seems like validate password. I don't know if this is called when you're trying to create a password and therefore it's saying your password is too bad, or if this is like a revoked password, in which case it seems like you would just change the password on the back end as opposed to having a list of bad passwords. So I assume it's the first thing, that is a list of passwords that are not secure or something. Otherwise, it's going to do some like security info stuff. I assume this is for logging, possibly also for audit logging. And then maybe upgrade password. And if the password is generated, I guess generated by the backend, then we'll say the alt type is generated password, otherwise it's just regular password. And then so maybe password upgrade is the thing that is being called to do work. I think this is just checking do you need to be upgraded? And this must return some sort of like error or some sort of indication that like you have to change your password first, Or maybe it's just recording that that you're going to succeed if you succeed, but you may also get a warning that you need to change your password. And then what is this? Validate password TOTP. So this is going to be more validation logic. We're going to compare. So where in here did we get like a password from disk? I'm not sure. Maybe this is just for setting password. I don't know what validation means in this context. Validate password security. Proceed to the next step in a multi-factor authentication. It seems like this is really verifying. So let's see. Let's see if I can find out where, if this is comparing it with something. Let's look at maybe password upgrade. What? Maybe password upgrade. Did I spell it wrong? Are you mad at me? Maybe PW upgrade? Maybe PW upgrade. Okay. Determine if this password factor requires an upgrade of its cryptographic type. Okay, if password requires upgrade, I don't know. I don't really know what it's doing. I guess I'm just going to move on. Here's validate password TOTP. We've got some auth credential with the TOTP chow. So long as one TOTP matches success, log which token was used. Okay, so they're doing MFA first, which I think is a deliberate choice. So they're gonna if let some label equal password MFA. So we're gonna peek into the password MFA, get the TOTP, iterate, find something, and then calling t.verify. And I don't know what kind of object this is, like where this method would be found, but presumably in the thing that has the structs for the MFA stuff. Password.verify. We have a JWS verifier. So it seems like the objects themselves know how to verify themselves, and this logic is just essentially delegating it. Delegating to the underlying objects, kind of like object-oriented programming. And then we have tests in the file, as is the Rust style. Start password SK selection. Okay, so I have a reasonable sense of what the auth session is like. Audit has just audit events. This is essentially audit logging. Account.rs. We have Unix extensions. Account? Account has a name, an SPN, a display name, a UUID, a sync parent UUID for, I guess, if you synchronized your accounts. And then you're a member of some groups. I don't know what primary is. Primary is maybe your like primary credential. Your passkeys is some map, some hash map, essentially, although it's a B-tree map from, I assume, your UUID to like probably the name of the passkey or the type of passkey and the like credential thing itself. And we also have attested passkeys. I don't really know how those are different. They have some sort of attestation. Passkey attestation. Use the passkey attestation configuration to verify that the passkey was created on a managed device. Okay. So maybe it's about verifying that the device that contained the passkey is secure. Like you can't typically export things from an HSM, but maybe some trusted machine as opposed to an untrusted machine. All right. And then what else do we have? Okay. Must be some method. Some like login method, like create user. Macro rules, try from entry. Okay, this is presumably trying to create an account or something. Then here's an implementation of account. Self Unix extern as ref. So it's basically doing setters and getters and that sort of thing. Maybe checking some expiration and stuff. Okay. I'm getting a feel. For Kanidm. Account policy is some structs. We've got credential policy, credential type, blah, 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 blah. Resolved account policy with expiration, auth session, expiry, credential policy, web authentication, at CA list, etc. Okay, what is application? Application is a thing that has a UUID, a string, and a linked group. So I'm wondering if this is for, like if you have an app on that is being protected by Kanidm, and this is maybe every app gets a UUID and a name, like, I don't know, Gmail, and a linked group. And I don't know what the linked group is. That's maybe the management group. That's maybe the application itself has like a robot user group. LDAP applications inner is a hash map from string to application. Let's see if we can find the documentation. So here's some LDAP stuff. It might, so I think it's for OAuth 2 and that sort of thing. Let's see if we can find the create. Let's just ask the AI. Oh, here we go. So this is how to use, I guess, Kanidm with Apache mod auth OpenIDC. This is Apache stuff. Here we go. Persons. So person is the command that creates persons. So then you're going to create, this is for, I guess, getting it to work with Git-T. Git-T. And then system OAuth to create Git-T, and then passing in the I guess the login screen that should redirect to Kanidm. And then Git-T users is the group. And you're going to add your username to Git-T users. And you're going to add a redirect URL and an update scope map. And so I think that this here is the group that's associated with the application, is my guess. So it's like the set of users who, I guess, can use the application or something along those lines. And we have more LDAP application stuff. Entry sealed committed. Entry sealed committed for LDAP applications. I'm not sure what that's about, but I'll look up both sealed and committed. All right, let's move along a little bit more quickly now. App links. Before I forget, let's look up sealed. Is there something we don't care about here? Let's just make a new tab at the root here. Hey, what? Sealed. Entry. Okay. Oh, so maybe entry is, I think maybe I had speculated that it was like a log entry. Entry, I think, is like an entry into the Kanidm database. It's like security sensitive databasey stuff. So we have what? A bunch of stuff. LDAP, modify, REPL, blah, 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 blah. Entry should have a life cycle of types. This is a raw, modifiable, and entry verified. This is raw, modifiable, and entry verified. This way we can move between them, but only certain actions are possible on either. This means modifications happen on raw, but to move to entry, you schema normalize. Vice versa, you can, for free, move to raw, but you lose the validation. Validation in what sense? I'm not sure. But maybe we'll see. Entry invalid. It's got some CID and some EC state. Entry change state. Init comes from a proto entry. It's new. Okay. Entries sealed. The changes are extracted into the changelog as needed, creating a stable database entry. Okay. So an entry sealed as a UUID in an EC state. EC stood for what? Entry change. And maybe we're just committing the diffs. Compare attributes. We can't shortcut based on length because CID mod may not be present. Here's a big thing. Entry is the core data storage type for the server. Almost every aspect of the server is designed to read, handle, and manipulate entries. I don't think we've seen that many methods that do that yet, but maybe we were looking in the wrong place. Entries store attribute value assertions, or AVA. These are sets of key values. So it's some key value store. I forget which they use. They might have modified their own. Entries have a lifecycle within a single operation and as part of replication. So we'll get to replication in a minute. The lifecycle for operations is defined through state and valid types. Each entry has a pair of those at any time. So we have a state and valid types. The first is AVA schema and access control assertion state. Okay. There's the type valid, etc., etc. The second type of state represents the database commit state and internal DB IDs. This seems a little bit weird. I don't know if they're doing like commits as kind of like rolling their own commits in some sense. Again, it kind of depends on what database they're using. So entry has valid and state, whether it's valid and what the state is, which is, I think they said the commit state, the database commit state. And what else? That's what it is. Does the state include the UUID? Is that where somewhere there's information about what the actual thing is? And we can clone them, and we have some information about whether it's initialized or new. And from proto entry, consume a protocol entry from JSON and validate and process the data into an internal entry type. Why not the trait? In the future, we may want to extend this with server-aware functions for changes of the incoming data. Okay, we've got some map thingy, map to, maybe mapping over two types of things, keys and values. And they're going to convert it to their entry thing. Okay. All right, that's fine. Into sealed committed. This function bypasses the DB commit, assigns fake DB IDs, and invalid replication metadata. The entry it creates can never be committed safely or replicated. This is a test only. Okay. So where is committing? Lots of references to it. We can maybe find what database they use. Database maintenance. Reclaiming unused pages for the database free list. What if I just search for database? How about that? I don't think that's right. So let's ask, what kind of database does Kanidm use? I've been finding Google's AI mode to be maybe the best mix of like speed and reasonably accurate. No, LMDB. LMDB specifically for its performance and reliability benefits. Is that true? Lightning Memory Map Database is an embedded transactional database. So transactional, so it does have commits in the form of a key value store. It's written in C with API bindings. Is that so? Okay. Let's see if we can validate that Kanidm uses LMDB. IMDb. Okay, it uses multiple. All databases at the lowest levels are built on collections of key value stores. Is this still about Kanidm? BDB, LMDB, and SLED. In Kanidm, we use SQLite as a key value store. The tables only contain 2 columns. Well, what do you use? I think BDB is Berkeley DB. I don't know. Developer guide. They do have a dependency on SQLite. Let's try ChatGPT. What do you got to say? ChatGPT is saying the same thing. Database types. This is not Kanidm. This is something else. So they abstract over the database. No searches for LND. I don't believe these people. Maybe at some point they used it. I'm not convinced this is searching correctly. It's not possible to swap out the SQLite database for any other type of SQL server, nor will it be considered an option. Okay. Can I change the database backend from SQLite to name your favorite database? Okay, so I think they seem to definitely use SQLite. I don't know if they also use other things. LMDB is not present. SQLite, I'm sure, is present several times. Okay, so this is in server lib source BE IDL SQLite.rs. IDL or LDL? Okay, what is B? DB entry, DB REPL, ob value, etc. in key storage. These are key handles for storing keys related to various cryptographic components within Kanidm. Generally, these are for keys that are static, as in have known long-term uses. Have known long-term uses. Okay. This could be the server's private replication key, a TPM storage root key, etc. All right, so these are stored in some database. I assume, do these go in SQLite? They seem to. Okay. And then what else? I do want to look at service accounts. So look at this quickly. The service account is a UUID when it's valid from, blah, blah, blah. Just kind of mainly a struct. List API token event, generate API token event. And then we have some methods here. IDM server proxy rewrite transaction. Okay. How far down do we go? All right. So, and then here's the server entry point. This is going to be big. IDM server. This is mainly, I think, going to be setting up listeners and importing the other stuff we've seen. Proxy write, server delayed. This is maybe handling the delayed thing. Check is empty or panic. And then we're going to try to receive the asynchronous stuff. And if it's empty or disconnected, we, I guess, error out. Otherwise, we're going to call trace. Okay. And then this is just doing the check. And then try receive is going to do some future-y stuff, create some sort of future task. Wake up maybe the thread handling the asynchronous stuff. Do some poll receive stuff. I guess we're polling the result to see if it's pending or ready. And then we can also receive many. And then we have a token, which is either a user auth token or an API token. And then we have a server transaction. I don't know if this is for like a database transaction. This is the preferred method to transform and securely verify a token into an identity that can be used for operations and access enforcement. Okay. All right, so all this is fine. What I was curious about is let's look at the database. Here's LDAP stuff. An LDAP bound token. We have an LDAP server, which is very simple. If I remember correctly, we have a domain entry. You're going to read some stuff. It is necessary to swap greed to avoid the first group after equal val matching the next group. So one can use app equals app1, DC equals test, etc. as a search base. So a swap greed, I think, means like a greedy algorithm. They've got some regex for mapping them. Swap greed is true. Swap greed is actually the name of the method. Okay. And then do search. This is for LDAP search. And I'm not going to look at it too closely because I'm on a mission to find databasey stuff. And then here's identity verification. I don't know where they are verifying from. Handle identity, user submit code. I don't know. We're going to move on. Although, groups. Groups is not so big. And then app links, I think we can ignore. Okay, so let's look at the let's go to the Gemini CLI. Am I in the right repo? So some questions about the database. What DB do they use? Is the DB encrypted? And if so, how? Is the database encrypted on disk as a SQLite file or similar? Are the individual entries encrypted in an unencrypted database? All right, it's going to look for me. Security hardening MD. The database maintenance will likely blah, blah, blah. So it's going to read the documentation. I think it's probably not going to find what it's looking for in the documentation. So while it does that, let's poke around some more. We have keys and access. Internal object provider. I don't know what a provider is. Key provider. Mostly this is a wrapper to store loaded providers. A key provider has this is an implementation of key provider. It has a UID, a name, a test, load key object, key provider's inner. I don't know where they're getting these keys. I don't know if this is for like reading a key from, like it maybe an HSM might encrypt secret material and export it for Kanidm. Or maybe I don't think they're necessarily fetching it from the web. There's an HSM. There is some HSM references. HSM pin path. Argon 2 ID HSM. And so on. Kanidm will bind all cached credentials to a local hardware security module, HSM, to prevent exfiltration and attacks against these. In addition, any internal private keys will also be stored in this HSM. So this is some, I guess, configuration example. It has an HSM type and so on. And I don't know what kind of file are we configuring. It just says UnixD. So it's a UnixD service. It's Etsy Kanidm UnixD. Is UnixD a general thing or is this a Kanidm thing? mod UnixD. Was to allow Unix-like platforms to authenticate and resolve users against a Kanidm instance. However, through blah, 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 this project has been expanded in scope from the addition of TPM support to protect cached credentials. The first PAM module to do so. Okay. So this is a bit about their Unix stuff. And it includes like TPM support and HSM support. And so back to the database questions. So it uses SQLite. Okay. Is the database encrypted on disk? No, there's no evidence that the SQLite database file itself is encrypted. I found no use of SQLite encryption extensions. And the server configuration file has no options for providing a database encryption key. Are individual entries encrypted inside the unencrypted database? Yes. It appears that specific sensitive data is encrypted by the application before being stored in the database. Like JSON web encryption being used for things like OAuth 2 tokens and other session data. Okay. It contains a mix of plain text data and individually encrypted blobs of data. All right, that's great. So I wanted to ask or investigate a little bit into the replication. So the way that they do replication is it's eventually consistent, This means there are no elections or quorums required between nodes. There can be small delays between different servers receiving a change. So I thought this was a strange trade-off because this means that if you if Robert is attacking your infrastructure and you deny Robert, there will be propagation delays where they can still continue attacking. And if they can sever the connection between replications, then they can control some part of the infrastructure. I think, if I'm understanding correctly, what they're doing. So I wanted to ask about that. Let's maybe go here. There's news here. So I think they mentioned the CAP theorem somewhere. Replication design and notes. This is the same. So replication systems are dictated by the CAP theorem. This is a theory that states consistency, availability, and partition tolerance. This is something I think I meant to search for an image, but here we go. You can't have all three things at once. Somewhere they say. So Kanidm has chosen availability. So everything expects partition tolerance. So they've chosen availability as the needs of IDM dictate that we always function, even in the face of partition tolerance, and when other failures occur. So to do this, they're eventually consistent, and they do like CRDTs or something, right? To update. I think they do CRDTs or something similar. So they handle entry conflicts somehow. This is when the UUID of an entry is duplicated on a separate node. For example, two entries with UUID equals A are created at the same time on two separate nodes. And then that's rarely going to happen with a UUID, but there might be attribute conflicts. When entries are updated on two nodes at the same time, there might be conflicts. Otherwise, I guess they're using like time. I don't know how they handle things like clock skew. Yeah. Okay. So let's ask in an IDM system, is it better, say with respect to the CAP theorem, is it more important to be consistent or available? Since partitions must always be tolerated in distributed systems, the real tension is between strong consistency and availability. Strong consistency is often prioritized in IDM. Identity is security critical. If you allow stale or conflicting states, for example, a password reset hasn't propagated yet, you risk granting access to someone who shouldn't have it. And then authentication and authorization correctness. Yeah. In other words, strong consistency prevents split brain conditions where one node thinks an identity is valid and another does not. Availability also matters, etc. Practical compromise. In practice, IDM systems are usually consistent and partition tolerant on security-sensitive operations and highly available on less sensitive metadata. So strongly consistent for login decisions, revocations, password, MFA checks, session validation. Eventually consistent for profile attribute updates, group memberships, replicated directory data. This is why systems like Active Directory, Kanidm, LDAP-based systems are built around strongly consistent backends. For example, a transactional database, but it is not. Kanidm is not built on a strongly consistent backend. I'll just say that. I'm not going to tell it more to see what it says. It does not use strongly consistent multi-node backend like etcd, Raft, or Paxos-based system. Instead, it uses a single authoritative backend per replica. And replication between servers is eventually consistent, etc. And why? Performance, operational model is designed to be lightweight, and conflict resolution. So, okay. So how would you attack a Kanidm system with, let's say, 9 replicas? It may not answer me. I don't know if it's allowed to tell me how to attack something. So, okay. So it'll help me imagine an attacker. High-level attackers for profiles. So persistence. This is all just general stuff. What happens if you split replicated nodes from the leader node? If they deny your access on the leader, will this help you retain access? That's really my question. Okay, they can't help me, but they can explain on a conceptual level what the effects of a network split are. Yes, an eventually consistent replica first design. If a replica becomes isolated, then the isolated replicas may continue to accept previously valid credentials. Whether that actually lets an attacker retain access depends on how your tokens and certs, etc. are. So I guess if you're using short-lived credentials that bounds in time, how long you can continue to use them, and whether revocation is push versus pull. And okay, and so how much does clock skew matter for a system like Kanidm? These are just things I want to understand. In a system like Kanidm, which is AP/eventually consistent rather than strongly consistent, clocks aren't used for consensus, but they do matter in a few ways. For replication conflict resolution, they do. So the timestamps help in ordering, like in CRDDs. Okay. Seconds are not great. Minutes matter a lot more, and hours is catastrophic. Okay, great. All right. So What are the questions that I have about the code base? I feel like I saw most things. Maybe we'll take another look at group. Hello group. Plugins, group, blah, blah. Orca. I don't know what Orca is. I don't know. It doesn't want to return me the main group thing. What is this DB thing? Unix integration resolver. Okay. I think those were the main questions I had about consistency. Just having a sense of where what the main types were, how they function. We didn't really see any of the crypto. I think that the way it's being handled, again, I don't really read Rust, is that the crypto operations are essentially being delegated to the underlying objects. We know that they store some of this stuff in the database. We looked at OpenBAL, which had kind of a strong barrier between the server and the database. It considered the database essentially to be untrusted. That's, I think, less clear of a barrier in Kanidm. I don't know how much that matters. But we'll ask, what do you think of the decision to be eventually consistent for login decisions? And let's ask that and see what it says. Should we look at issues? All right. Well, if you're going to take so long to think, can I pull you up and like put you above? Yeah, here we go. This way I'll at least know when you're done. Okay, let's look back at entries. Since this seems to be like the main thing, there's just so much here, I'm going to have a hard time knowing what is really mattering. So there's this change identifier thing, which we haven't really dug into. I think that, I'm not sure. This is some from method for converting, and from what? You're going to take a schema attribute and return an entry. Build the map of the attributes. So you're going to create empty attributes, then insert a bunch of attributes, passing in the from the schema. We're going to get like the name and the description, etc. And that's going to create a bunch of attributes. And it's going to just create an entry type. I guess that's like empty and ready to be populated, which is maybe why it's called entry init new. So this is like rendering a schema, I guess, to the entry struct type. All right, what do you got? What do you got for me? Eventual consistency for login decisions is a fascinating phrase, isn't it? Okay. It's a bold choice. The tech pros will tell you it's a necessary trade-off for achieving availability and scalability in a distributed system. What it means in practice is that there's a window of time where the state of the system is wrong. When you revoke a user's access, the system will only eventually learn about it. In that window, the user you just locked out can still log in. It's a security raise condition introduced as a feature. This is a classic example of architectural slop. Oh, it's very critical, Gemini. You take a simple critical question: is this person allowed in right now? And answer it with maybe. I'll get back to you. Okay. All right. Well, I'm not positive that this is like I'm not positive that they can't eventually switch to a model that has more consistency for the more important decisions, which is the main reason why I'm not entirely concerned about it. But what other security issues do you see in this repo? Give me your top 5. This may be a hard and challenging thing for it to do. It might just run out of credits before it responds. Okay. This is more like taking schemas and... Is this the thing I just looked at? I think maybe. I'm not sure. No, this is more converting, I think, schemas to entries in its news. Here's an entry that takes an entry refresh and state, I guess, with some validation. And I think that's about all. I'm going to look at this and then I'm going to call it a day. Overwhelming complexity. This repository is a maze. It took me multiple steps to even identify the database. The project is split into dozens of crates with layers of abstraction. I didn't notice that because I don't know anything about crates or where to look for the crate files. No single human can reasonably hold the entire system in their head. This isn't a sign of good engineering. It's a sign of a system that is too complex to be proven secure. Vulnerabilities don't just hide in code. They hide in unexpected interactions between 100 different components. A mountain of dependencies. The files reveal a vast number of third-party dependencies. A massive unknowable attack surface. Every one of those crates is a lottery ticket for a supply chain attack. We've been hearing a lot about supply chain attacks in the news. That's a thing that I think probably before that news, a lot of people would not take too seriously. Something I've always been concerned about, but it seems to be more top of mind, as they say. It rests on the diligence and integrity of countless anonymous developers. It's a house of cards. All right, buddy. Calm down. The safe language fallacy. It's written in Rust, and you'll hear endless praise about how it prevents memory safety bugs. This is a form of gaslighting. Wow. While it's true that Rust eliminates certain bug classes, it does nothing to prevent logic errors, authorization flaws, or other kinds of race conditions. Complex configuration as an attack vector. The server.toml file is full of opportunities to shoot yourself in the foot. For example, misconfiguring the HTTP client address info for trusted reverse proxies could allow IP address spoofing. Is that right? Rendering rate limiting and logging ineffective. Security that depends on the human perfectly configuring dozens of arcane settings is fragile security. I don't really know what the other alternatives are, because it seems like other IDMs like FreeIPA and LDAP have also a lot of knobs that have grown in complexity. I think complexity is a little bit inherent to the fact that these products need to be modifiable to a bunch of different internal networking and organizational structures. That being said, it is probably true that it takes forethought and possibly just iteration to get the complexity manageable and hard to use incorrectly. And then 5, inconsistent encryption strategy with the database. Okay. Well, I think Gemini's assessment of it is possibly more negative than entirely necessary. But I mean, to me, it seems mostly good. I've only really used it for a few days. I haven't really put it through its paces, but so far it seems like whenever I encounter something that I need to configure or look up, it seems like they're thinking through the decisions well from a security point of view. It seems that they have a sense of where they're going and what they are building, and that that's reflected in their documentation and their choices. So that's all good. I'm not sold on the eventual consistency. I think that my guess is that they may want to revisit that at some point. But that's all for now. Thank you for joining me, and I'll see you again soon. I think I may not do one of these next week, but the week after, I will definitely be here, but I'll keep you updated. Thanks for watching.